This is going to be page 4 of test 3-2 review, which is going over the Pythagorean theorem. And will be questions 16 through 20. So for number 16, it says the width of a rectangle is 14 inches and its diagonal is 50 inches. We want to know what is the measurement closest to the length of the rectangle in inches. So I'm going to go ahead and draw a rectangle for us. And it says the width is 14 inches. And its diagonal is 50 inches. Now remember, diagonal is the length from corner to corner. And we want to know what is the length of this rectangle. So after identifying your 90-degree angle, we're going to draw an arrow and it points to C. I'm going to label 14 as A and we are looking for B. So I am going to write down our formula, which is A squared plus B squared equals C squared. So A is 14 squared. I am looking for B squared, and this equals C squared, which is 50 squared. I'm going to simplify our exponents. So 14 squared equals 196, plus B squared equals 50 squared, and 50 squared is going to equal 2,500. Next, since my numbers are on opposite sides of the equal sign, since I have 196 being added to B squared, I'm actually going to go ahead and now subtract 196 to both sides. This cancels out. I'm left with B squared equals 2,500 minus 196, which equals 2,304. Now my last step is going to be to take the square root on both sides. So I'm going to take the square root of 2,304. And the square root of 2,304 is going to be 48 inches. So here our answer is going to be A. For number 17, it says when 3 squares are joined at their vertices to form a right triangle, the combined area of the 2 smaller squares is the same as the area of the larger square. We want to determine of the which 3 squares, we want to determine if the 3 squares support yes or do not support no this statement. So remember, again, when we add the area of our 2 smaller sides, it should equal the area of our largest side. So our first step is actually going to be to find the area of all of our squares. Now, if you notice here, there's a difference between we have units squared and we have units. If it says units squared, that is already your area and you do not want to do anything else to it. If you have no exponent, then that is your side length and you need to square each side length to find the area of that square. So for 6, I'm going to go ahead and leave it alone because this is already an area. I need to square 8 to find the area of that square. So 8 squared equals 64. So this is 64 units squared. And then I have 14 squared for my largest square, and this is 196 units squared. So when I add these two sides together, when I add 64 and 6, it does not equal 196. 64 plus 6 equals 70. So again, 70 does not equal 196, so therefore these 3 squares would not be able to form a right triangle. Looking at the next example, we have 169 units squared, 25 units squared, and then we have 12 units. So these 2 squares are already it's already given the area of these 2 squares. I just need to find the area of this last square. So I'm going to square 12 squared. And 12 squared is 144 units squared. So again, I'm going to add the area of my 2 smaller sides. I see that these 2 are the smaller areas, so I'm going to go ahead and add them together. So I'm going to take 144 plus 25, and I see it equals 169. So yes, this would be an example of the Pythagorean theorem. Then let's go ahead and look at the next one. So they have given us 5 units, 13 units, and 12 units. So again, these are side lengths. I need to know the area. So we should be squaring this. So 5 squared equals 25 units squared. We have 13 squared equals 169 units squared. And then we have 12 squared. And 12 squared equals 144 units squared. So then again, we want to add the area of our two smaller sides, which are going to be 25 and 144. We want to add these together and we want to know, does it equal 169? So 144 plus 25 equals 169. So yes, this is going to be an example of the Pythagorean theorem. Okay, then let's go ahead and look at the last one here. So again, they've given us two areas and they've only given us one side length. So again, we want to go ahead and find the area of this square. So if this side length is 10, to find the area, I'm going to go ahead and square it. So 10 squared is 100 units squared. So again, this is going to be my largest side because it does have the largest area. So then I'm going to go ahead and add together my two smaller sides. I'm going to add together 125, and I want to know, does it equal 169? Well, 100 plus 25 equals 125, which does not equal 169. So there is no way that three squares would be able to be an example of the Pythagorean theorem. Next, let's go ahead and look at 18. So number 18 says, what is the hypotenuse of a right triangle with legs that are 4 inches and 7 inches? So you should go ahead and draw yourself a right triangle. And I'm going to go ahead and label the legs as 4 and 7. So I'm going to identify my 90-degree angle and draw my arrow to C. So 4 will be A, 7 will be B. So my formula was A squared plus B squared equals C squared. So for A, we have 4 squared. Plus B is 7 squared, and this equals C squared. Let's simplify our exponents. So 4 squared equals 16, plus 7 squared equals 49. And this equals C squared. Let's simplify that. 16 plus 49 equals 65. And this equals C squared. Then my last step is to take the square root on both sides. So the square root of 65 equals 8.06, which when we round is going to be 8.1 inches, which means that D is our answer. Okay, for number 19, it says 3 squares are joined at their vertices to form a right triangle. The figure below shows the area of 2 of the 3 squares. What would be the area of the third square? So first, we should identify our 90-degree angle, and we see here that this points to C. So C squared equals 625. I'm going to go ahead and label this side as A, so A squared equals 49, and I am looking for the area of B squared. Now remember, when we add together the area of our two smaller sides, it equals the area of our largest side. However, they've given us the area of our largest side and one of our smaller sides, and we're looking for the area of one of the smaller side. If I were to show this to you algebraically, which might make a little bit more sense to you, I have A squared plus B squared equals C squared. So I'm going to substitute this information. So for A squared, we have 49, and I do not have to square this because whatever side length I would have gotten, when I square it, it equals 49. So it kind of eliminated a step for you. So we have 49 plus we are solving for B squared, and this equals C squared, which is 625. So again, I don't have to square this because it's whatever side length I have here has been squared. So since I have numbers on opposite sides, I would subtract 49 from both sides. And when we subtract 625 minus 49, we get 576. So here, B squared equals 576. So here your answer is C. But again, like I mentioned, when we add together the area of our two smaller sides, it equals the area of our largest. So all we had to do here was take the area of our largest and our smallest and subtract them to equal B squared. Lastly, let's go ahead and take a look at number 20. So number 20 says, Oliver was cutting down a tree in his backyard with an axe when it finally split and fell. The stump that was left standing measured 5 feet, and the top of the tree landed 12 feet away from the stump. How tall was the tree before Oliver cut it down? So that key word is before. So whatever we do get is the hypotenuse of our problem, we need to add it together to 5 feet because it wants to know what is the height before that tree fell. So I'm going to start off by identifying our 90-degree angle and drawing our arrow to C. Here we see that the height of the stump is going to be 5 and the base is 12. So we have a squared plus b squared equals c squared. So for a we have as 5 squared plus b is 12 squared, and this equals c squared. 5 squared is 25 plus 12 squared is 144, and this equals c squared. 25 plus 144 is 169, and this equals c squared. Now our last step is to take the square root on both sides, and the square root of 169 is going to equal 13. So here c equals 13. However, the height of the tree would be 13 plus the 5 from the original stump to give you 18 feet, which means your answer here is D. And that is going to complete your test review.